Hi there and welcome to Mr. T's Maths. In this video, I'll be showing you how to convert recurring decimals to fractions. Let's go ahead and see how we can change these recurring decimals to fractions in their simplest form. Let's start with a simple example, 0.7 recurring. Okay, so the first step is to let x be equal to 0.7, and instead of using this notation, I'm just going to use 0.777. So I'm going to write the recurring decimal a couple of times, the recurring digit. Okay, now your aim is to always have this repeating digit, yeah, in this case the 7, in front of the decimal point. So to achieve that, in this particular example, we have to multiply this x by 10. So if x is 0.7777, then 10 lots of these x's would be 7.777 and going on forever. Okay, now if we just write this the x underneath that, let's see, we have x equals 0.777. You might observe that both expressions, yeah, have the same decimals, yeah. Look at this, 777, 7777. So if we were to subtract these two, yeah, this represents, we've just manipulated both sides, yeah, but it actually represents the same proportion, let's say, yeah. So if we were to subtract these, we would get 10x minus x, 9x equals, and check this out, imagine that these you start subtracting these decimals, yeah. 7 minus 7 is 0, 7 minus 7 is 0, 7 minus 0, so 7 is 0. So eventually you will end up with a whole number, 7, yeah, because these digits, since they are the same, okay, everything after the decimal point will just end up being 0. So you have that 9x is equal to 7, and therefore x equals to 7 over 9. So now if x initially, yeah, initially x was equal to 0.7777, and now we've just showed that x can also be written as 7 over 9. Do you agree that 0.7777, yeah, so 0.7 recurring can be written as 7 over 9 in fraction form, yeah? So that's basically it, yeah. We always have to think of a way to bring these repeated digits like 7 and 9 in the next example in front of the decimal point, and then find another multiple of x that will have the same values, the same digits after the decimal point. So let's go ahead and continue with this, yeah. Let's look at this next example, 0.79. okay, so here x will be equal to 0.79, the two dots means that 7979, yeah, this group of the two digits repeats itself forever. Okay, so now we want to bring this 79 at the front of the decimal point. Therefore in this case we have to multiply by 100, so 100x is 79.7979 and so on, yeah. And as we can see, if we take away x, yeah, 7979, we will end up with a whole number. 100 minus x is 99x equals to 79 minus 0 is 79. So once we have the same digits here after the decimal point, we can just assume that when subtracting these, yeah, these will actually end up being 0, 79.0000, yeah, which is just 79. So therefore x is equal to 79 over 99, okay, which is in the simplest form, yeah. So 0.79 recurring is equal to 79 over 99. All right, there you go. Okay, I have two more examples. Yeah, as you can see in this one, the digits 1, 2, 3 are repeated, and in this one here we have 3, but then it's 4, 7, 4, 7, 4, 7 on, going on forever. Yeah, so feel free to pause the video at some point and have a go on your own. If not, just keep watching. Let's go. So we are going to let x be equal to 0 point, and just to make it clear, this is 1, 2, 3, 1, 2, 3. Yeah, so the three digits repeat itself. Yeah, so we have, okay, now what should we do? If we multiply by 10, it's going to be 1 point. No, that's not what we need. We need to bring this collection, this group of digits, ahead of the decimal point. So we will have to multiply by 1000. Yeah, that's what will help us achieve what we want. So 123.123, and so on. Yeah. And now, as you can see, x equals, by leaving this x equals 0.123, we have the same numbers, the same digits here after the decimal point. So we can leave it that way, x equals, and we can subtract these two. 1000x minus x is 999. X equals to 123 minus 0. As we said, these decimals will just disappear. We will end up with a whole number. Okay, so x equals 123 over 999. At this point, yes, make use of your calculator. This can actually be further simplified to 41 over 333. Okay, so therefore 0.123 recurring can be written as 41 over 333. All right, and the last example, yeah, it's 0.3474747. So again, we are going to let x, in this case, be equal to 0.3474747, going on forever, right? We want to bring this group of recurring decimals in front of the decimal point, so we will have to multiply by 1000 again. 1000x equals 347.4747. As you can see now, after the decimal point, we just have the group of repeated digits, yeah, 4747. Now, if we subtract x, can we subtract x? Well, yeah, we could, but if we subtract x, yeah, we won't get rid of all the decimals. We will still have a decimal number. So we should really multiply x by 10. Okay, and if we multiply it by 10, you will see that we end up with 3.4747. And now, if we subtract, then these decimals will disappear. Yeah, we have 1000 minus 10 is 990. X equals to 347 minus 3. Yeah, 347 minus 3, which is 344. So now we rearrange, we make x the subject, 344 over 990. Go ahead, use your calculator, or just do it if you are allowed. Yes, you are in the IGCSE. You are allowed a calculator in this exam. If you are doing GCSE maths, depending on where this problem appears, you might have access to a calculator or not. Yeah, so this is 172 over 495. Okay, so yes, as you can see, 0.347 can be written as 172 over 495. Okay, well, I hope you found this video useful and you feel much more confident when converting recurring decimals to fractions. Take care.